All right, so getting into chapter 15, a little more working with some probability stuff. A lot of these things are found either in calculator. We also have formula packet for a lot of the things in here. So the one that we're dealing with in this video is based on what we call the expected number, which we dealt with expected number earlier on in the year. But this is something real specific to this particular chapter as well. So we have an expected number or a mean frequency for something like this. So right here in your formula packet is really key to what we're going to be working on for chapter 15 here. So pay close attention to these formulas, but this is the one we're looking at in this video. So if we have an expected number of something, also known as the mean value. So this is something, again, we saw earlier in the year. Simple little formula. It's the number of trials times the probability of success. So keep that one in mind. I'm going to be referring to that one quite a bit in this video. So here we go. In a table scenario, and this is often the way that you're asked to do this, you're going to be asked to fill out a table as well as to work with numbers from a table. So these tables are really key to this section. So take a look. So they're going to say the probability of some event happening is the probability of that specific item happening within a set of data. Yeah, that couldn't be a lot. They could have made that a lot simpler, but here's basically what they're saying is that little x is an element of this set of data. And so they're saying the probability of this happening within that set of data is the probability of that event. So yeah, anyway, so if we wanted to fill out just the probability of certain things happening, well, in this problem in particular, they gave us a little formula to work with. So they're going to say the probability of x happening, the probability of getting this, is based on this formula. So if I sub in the elements of that data set, so if I plug in a 1 right there, 1 plus 2 is 3, 3 times 1 over 18 is the probability of getting a 1. If I want the probability of getting a 2, then I sub in a 2 for x, and that's the probability of getting a 2. Sub in a 3 to get this, sub in a 4 to get this, and those are the probabilities of all of my outcomes. So if we just said, what's the probability of getting a 2 in one event, right? Well, it's 4 out of 18. That's the probability of me getting a 2 based on this scenario. Notice, as with all probabilities, all of your options must total 1. So this is really important, that the sum of all of those adds up to be 1, because there is no other option. I have to either get a 1, a 2, or 3, or a 4. There's nothing other than that listed in that set of data. So if those are my only possible outcomes, that must represent 100% of the outcomes. So, but if I did add all those up, I get 18 out of 18. And so the sum of my probabilities equals 1. So that's what's saying in that one. So they're going to give you some easy questions like this one. As long as you recognize that these have to add up to 1, this is really easy to answer. So if I said 0.3 plus p plus 0.1 plus 2p equals 1, so that's what you're seeing in this setup. Really simple. We can solve for p. And then if we needed to, we could now sub that back in to answer some questions if they asked us to. But anyway, that's the way you would solve for p in a case like this. As far as using graphs, you're going to see two diagrams given here. This is really not the common way of doing it. If you're an IB student and you use this concept within your internal assessment for IB, this might be something you would want to include. But realistically, a tree diagram is the best way to go for cases like this. And we dealt with tree diagrams earlier within probability. This is the one that tends to make the most sense to people. So if I look at tossing a coin 3 times, so the way this chart is laid out, x now represents the probability of landing on heads. So this would be a case where I got no heads out of the 3 tosses. So remember, this is being tossed 3 times here. So this would be the case of not getting any heads at all. So this is the case where I got tails, tails, tails. This is the case where I get 1 heads and 2 tails, 2 heads and a tail, or 3 heads. If you laid those out with a tree diagram, this becomes really clear. So look at the number of ways I could get 0 heads. Well, if I look at those 8 outcomes, right, 1 out of the 8 is a case with no heads in it. And so that's what we put in there for the probability of 0 heads is 1 out of 8. The probability of getting 1 heads, so if I look at the case where I get 1 heads, so there's 1 right here, 1 right here, and 1 right here. 3 out of the 8 cases get 1 heads. And so that's that probability. 3 out of the 8 cases have 2 H's. 1 out of the 8 have 3 H's. And that's obviously this case right here. That's 1 out of the 8. And so using that tree diagram becomes really helpful to answer a question like this. But now based on those, and again, you'll notice you can always kind of check to make sure you did this right. If I add those 4 answers together, I'm going to get 8 out of 8. And so I get 1 or 100% of all the probabilities within that diagram. So tree diagrams are really helpful when it comes to probabilities and filling out the frequency charts like this one. All right, so as far as getting the expected value, and this is the formula that I pointed out towards the beginning of this lesson that you have in your formula packet. It's just the number of trials times the probability of success. And so this looks a lot more complicated than it needs to be. Go with the one that I showed you at the start of this video. It'll make a lot more sense. So if I wanted to do the expected frequency for getting a heads on the coin, so here's the chart that we just filled out a minute ago. So if I said, okay, if I really did toss a coin 8 times, what's the probability, or how many times do I expect to get heads? If I were to toss the coin 8 times, toss the coin 3 times, how many times do I expect the coin to show an H, or to show heads? And so that's what we're finding with this. And so if you use the formula I showed you at the start of this, remember it's the number of trials times the probability of success. So we're saying, or the number of outcomes. So if I said 0 times the probability of success, so 0 heads times 1/8 plus number of heads times the probability of success plus number of heads times the probability of success plus the number of heads times the probability of success. So I'm just using that little formula, n times p, to get this answer. So that's what you're seeing laid out right here for my expected frequency of heads. So notice on this one I get 1.5. So what they're saying is if I really tossed a coin 3 times, well, the probability of me getting an H is 1.5. Obviously this is theoretical, not experimental. You can't get half of a heads if you toss a coin 3 times. So this is just a theoretical result. But consider this for a minute. If I'm going to toss a coin 3 times, the probability of getting heads is 50%, right? So, well, what's 50% of 3? If I'm going to toss the coin 3 times, then half the time I'm going to get heads. The other half I would get tails. And so that's why this should make sense to you. But this is just a calculated way of getting that result. So in a 50-50 case, it's a little easier to see where this number is coming from. So here's a case where it would obviously be a little less clear. So now if I were to try that with this one, and this is one you can try by on your own here if you want to pause the video. But again, I'm using the formula from our formula packet, which is NP. So the number of outcomes times the probability of that outcome. So the number of X's times the probability of getting that X plus N times P plus NP plus NP, and this is my expected frequency, or the mean result from that data. Yes, this really is like a real life thing. So if you're saying at this point, when would I ever use that in real life? Sorry to tell you, but statistics is everywhere. You can always use stats in real life stuff. So this is like just an insurance example here. So we're talking about $2,000 car, and they want to know, the insurance company wants to know how much they could expect to have to pay out for an insurance policy here. So if we were saying, well, for the $2,000, the probability of payment on something like this is 3%. They might have to pay 5% based on that number, 6% based on that number, 86%. They might have to not pay out anything. And so in most cases, people don't use their insurance at all, is what they're saying for something like this. So anyway, if you did the little n times p on this one, plus NP, plus NP, plus NP, they're coming out with $140. So the insurance company would say, this is what we expect. This is the expected frequency, or the mean payout. So if they're expecting to pay out $140, they got to make sure they're charging you more than that in order to make a profit. So moving on here, so a little more work with just the formula. Here's the last example, but this is a real classic IB style question. So this is really something you want to pay attention to. So here we go. They're testing you on two things that we learned in this video. One would be, how do I solve for K? And that goes back to the very first thing that we said in the video, where all the probabilities must add up to 1. So if I plugged in a 1 for X, a 2 for X, and a 3 for X, I know that those probabilities should all add to 1, because that's what probabilities always have to add up to, if you do this right, is 100%. And so that's your simple setup in order to solve for K. So here's what we get for K, is 36 out of 49. And here's the second idea that we learned in the video, is this formula, which is NP. So again, we're looking at the number of trials times the probability of success. And that's what we're seeing in the last part of this. So remember, the probability of success for this is now 36/49 over x squared. And that's how I get the probability of success. So on the first item, if I plugged in a 1, the probability of success is 36 over 49 over 1 squared. That's my probability of success, times the number of outcomes. So I have n times p, and that's going to give me the first scenario that you see here. If I wanted to do that with a 2, so this is my n value, this is the number of outcomes I'm looking for, times the probability of success. So if I plugged in a 2 right there, then I have 36/49 over 2 squared is the probability of success. So I got that probability of success times the number of outcomes. And again, I would do that one more time with a 3. So I have 3 for n. And if I plug in a 3, I get the probability of success. And so there's the setup for all of that. And if I clean all that up, this is what you get for your expected frequency, or the mean results.